Nintendo sold 101 million Wiis. Its successor sold 13 million, and it destroyed the biggest lead in console gaming inside a single generation. Nintendo's president, Satoru Iwata, had promised that this machine would win back the third-party developers who walked away from the Wii. And instead it drove them off faster than any console in the company's history. The usual explanation is marketing. Nobody could tell whether the Wii U was a new console or an accessory for the old one, and the name genuinely was a disaster. But that is not the mechanism, and I want to show you the mechanism because it is one specific engineering decision you can point at. To make the Wii U play Wii games, Nintendo had to build its processor around a chip design from 1997, not inspired by, not descended from, compatible with, down to the individual registers. And in the same year that Sony and Microsoft moved their consoles onto ordinary desktop processors, Nintendo shipped a machine that could not run the software everybody else was already writing. Rewind to 2011. The Wii had been the runaway hit of its generation, but Nintendo knew exactly what its weakness was. The Wii sold to families who bought 2 games, and the big publishers never took it seriously, because it was underpowered even by 2006 standards, and its audience did not buy the kind of games those publishers made. So the pitch for the Wii U was explicit. This time, we will have the horsepower. This time, the third parties come back. And Nintendo really did get commitments. Ubisoft, Electronic Arts, Activision, Warner, the launch lineup had proper multi-platform games on it. Then, within about 18 months, almost all of that evaporated. Electronic Arts, which had put a version of its biggest sports franchise on the machine at launch, stopped supporting it entirely. Ubisoft canceled announced projects, and the story you usually hear is that they left because it sold badly, which is true, but it is also backwards. They left because it was expensive to build for, which is why it sold badly, which is why they left faster. So here is the machine. The Wii U's processor is called Espresso. It has 3 cores, it runs at about 1.24 gigahertz, and it is a PowerPC 750 design. That number matters. The PowerPC 750 is the chip that shipped in Apple's first iMac. It is the processor family from the original G3 Macintosh in 1997. Nintendo had used it in the GameCube, where it was called Gecko, and then again in the Wii, where it was called Broadway, and each time it was widened a little and clocked a little higher and given more cache. Espresso is the third pass, and this was not laziness, it was a requirement. Nintendo had decided the Wii U would play every Wii game. There is no emulation layer doing translation. The console literally reconfigures itself into a Wii, which means Espresso does not merely need to be fast enough. It needs to behave identically to Broadway, right down to model-specific registers that almost no software should ever touch, because Wii games touched them. Once you commit to that, you cannot change the architecture. You can only add 3 cores instead of 1, more cache, a higher clock. What you cannot do is switch to the instruction set the rest of the industry is standardizing on. And that is what turns an old design into a fatal one because of when it happened. The Wii U launched in November 2012. 12 months later, the PlayStation 4 and the Xbox One both arrived, and both of them did something no console generation had done before. They used ordinary desktop processors. 8 x86 cores, the same instruction set as a Windows PC, in both machines. Think about what that does to a developer. Before, every console was an exotic architecture, and porting was a real engineering project. After, the PlayStation, the Xbox, and the PC were effectively one target. You built your game once, and shipping it on 3 platforms was mostly a configuration problem. And then there was the Wii U, sitting off to one side, running a widened Apple laptop chip from the 90s with 3 cores instead of 8, a different instruction set, different memory ordering, and none of the vector instructions modern engines had quietly been built to assume. A Wii U version was not a build target, it was a rewrite. Now the other half because there were 2 decisions and they compounded. The gamepad is genuinely impressive hardware. It is a controller with a 6-inch screen in it, and the console streams live video to that screen with a latency of about 1/60th of a second. 1 frame. To do that, Nintendo put a dedicated hardware video encoder in the console and a matching decoder in the controller and ran the link over its own 5 GHz radio protocol, separate from the Wi-Fi the console uses for the Internet. That is a hard engineering problem, and they solved it well. But look at what it cost. That silicon, that radio, that screen, that battery all came out of the same budget as everything else, and Nintendo was building to a price. Every dollar in the gamepad is a dollar not in the processor. So the machine that already could not change its architecture also could not afford a better one. And here is what turns it from expensive into useless. A second screen is only worth designing around if every platform has one. A multi-platform studio building for PlayStation, Xbox, and PC cannot make the second screen matter, because on 3 of their 4 targets it does not exist. So the feature Nintendo spent its budget on was, for exactly the developers it was trying to win back, structurally unusable. Put those together, because this is the take I actually want you to leave with. A publisher deciding whether to ship on your platform is doing one calculation. What does this port cost me? And what do I get back? The Wii U made the cost side enormous, an architecture nobody else targeted, a third of the cores, and a headline feature that only paid off if you did bespoke work for one platform. And it made the reward side small because the install base was a fraction of the others. Those 2 numbers are not independent, and that is the whole story. A hard port to a huge install base gets done. An easy port to a small one gets done. A hard port to a small install base never gets done, and the moment publishers work that out, the install base gets smaller, which makes the next port even less defensible. Nintendo did not lose third parties because of one bad quarter. It lost them because the machine's 2 defining engineering decisions were both on a publisher's spreadsheet reasons to say no. Backward compatibility is not free. It is a loan taken out against the next generation, and the interest is paid by every developer who has to target your architecture instead of everyone else's. So the reframe, the story you have heard, is that the Wii U failed because the name was confusing and the marketing never explained what it was. All of that is true. The name really was catastrophic, and shoppers really did think it was a tablet you bought for a Wii. But confusion is a demand problem, and demand problems are fixable. You rename it, you re-advertise it, you cut the price. What Nintendo could not fix was supply. It could not conjure a library it was never going to get, because getting one required publishers to rewrite their engines for a processor lineage the industry had left behind in order to reach the smallest audience of the 3 consoles. Nintendo's own studios shipped extraordinary games on that machine, and everyone agrees about that now. But a platform is not carried by its first-party output. It is carried by the 100 games nobody remembers, the annual sports titles, and the shooters, and the licensed tie-ins, and those are made by people doing arithmetic. The Wii U lost that arithmetic before it launched. Nintendo discontinued the Wii U on the 31st of January, 2017, a little over 4 years after launch, at 13.56 million units. The company posted its first annual operating loss in decades during that console's life. And then it did something that tells you it knew exactly what had gone wrong. The Switch, which arrived weeks later, is built on an off-the-shelf mobile processor with a standard instruction set and an enormous existing tool chain. It dropped hardware backward compatibility with Wii and Wii U completely. It has one screen, and the second screen is the same screen. Almost every decision is the Wii U's decision reversed, and it went on to outsell the Wii. The Wii U was not built by people who had lost their touch. It was built by people trying to protect what they already had, and the protection was the thing that cost them. If you want the earlier version of this exact mistake, Sega built a console that was even harder to build for. 2 main processors sharing one bus, drawing the world with the wrong shape, so that only Sega's own teams could get the best out of it. The Wii U had the wrong processor. The Saturn had too many. Same lesson, 17 years earlier. A platform runs on what an average team can ship, not on what a genius can extract. That one is on the channel now, and the link is on screen.